Chapter 5 is about fossil fuels, and when we talk about fossil fuels, what we mean are carbon-based molecules that we call hydrocarbons. That just means that they're made up of carbon and hydrogen. And so a few of them, starting from the smallest up to sort of a middle-sized molecule, would be carbon. The chemical formula is C. That's what primarily makes up coal. And then the next one is methane, which is carbon and 4 hydrogen. That's natural gas. And we keep going up. We go to 2 carbon that have 6 hydrogen. We call that ethane. Ethane is used to make another molecule called ethylene, and ethylene is in plastics. So you may have heard of like polyethylene, which is a type of plastic. And if we keep going, we get to propane, that's C3H8. We are familiar with propane from gas grills and heaters and things like that. Butane is the next one up. We find that in lighters, like cigarette lighters. Pentane is the next larger one. It has 5 carbons, and we use it to assist in making foams like styrofoam. It's not actually a component in the styrofoam, it's just used in the processing to make styrofoam. Hexane has 6 carbon, and it goes into making glues and varnishes and inks. It has some other chemistry related uses too as a solvent. With 7 carbon we have heptane. Heptane is used for dissolving things like oily things in chemistry. So if you have some sort of oily molecule and you want to make it go into a liquid solution, then you put that in heptane quite often. And then octane we're familiar with as gasoline, which has 8 carbons. So you can kind of see a counting scheme here. Pent for 5, pentagon would be another example of using pent as 5, hex for 6, hept is the prefix for 7, and oct for octane. You go up to nonane for 9, decane for 10, etc. So these molecules, they have a formula that is basically that you can have some number n of carbon, and then there will always be 2 times that number plus 2 more hydrogen that attach to it. And the reason why that is that for methane here, the carbon likes to bond in a what we call a covalent bond with hydrogen, and it can do that with 4 hydrogen. And carbon in general can share an electron with 4 different atoms if the other atoms are also willing to share one electron. And so when we go to something like ethane, we have the 2 carbon. Each carbon will have 4 things attached to it, but one of the things is a carbon. And so we have this carbon-carbon bond here. That leaves 3 other places for hydrogen to bond to each carbon. So you have C2H6, which follows this formula. If n equals 2, then 2 times 2 plus 2 is equal to 4 plus 2, which equals 6. So we get this C2H6. The next one up, well, not the next one up, we go to a larger one, pentane, with 5 carbon, and you can see the pattern again that each of the carbon bonds in a sort of a chain-like pattern here, and forms this linear looking thing with carbons, and then the hydrogen all stick off to the side. It's actually not quite true. In a 3-dimensional world, you see these bends in the carbon to carbon, so this is carbon to carbon here, and then these are the hydrogen, the smaller white atoms are the hydrogen. And so the structure is a little more complicated, but it still follows the same pattern where once a carbon bonds to another carbon, it only leaves 3 bonds there, but this carbon, for example, it's bonded to 2 other carbons, so it only has 2 other places for hydrogen to bond. And that's true for this carbon, and this carbon. And so that ends up leading to a slightly different looking structure where the ends have 3 hydrogen, but the ones in the middle have 2.